Yeah. Hi, guys. Welcome to this session. So, in this session, we are gonna learn a few miscellaneous topics in Python and also object-oriented programming in Python along with exception handling. So, let's get started. Let's say we have two lists of same length and we want to associate the corresponding elements with each other. For example, let's say we have names and then their respective ages. We want to associate them inside a tuple with first index being the name of the person and second index being the age of the person. Then we will use something known as zip. This zip takes two parameters, which are nothing but the corresponding iterables, which are two lists in our cases. And then we will wrap that zip around a list function in order to get list of zipped items. So if I run this, you will be able to get it like this. What if we have a array of different length? Then we will not be, then this last element will be ignored as it's not having the corresponding element in ages. And then if we want to unzip it, so then what we will do is we will pass this zipped item with asterisk symbol to the zip function, and it will be unzipped into two lists, two tuples actually. And I have given the names and ages. So these things will be printed out. And any doubts, guys, in zip?
Yes, Mahesh. So
Yeah.
what is the use of zip and how is it um, different from maps tuples?
Yeah, sure. So let's say you got results of two things. One is student names and then student marks in two separate lists. And you want to associate each student with their corresponding marks in this fashion. The first index will be the student name and second index will be the student marks. Okay. So in that scenario, you will use zip. Of course, this can be achieved using for loop and all. This is just another way of uh, using Python functionality to write the zipped code.
I thought it will be helpful in memory or something because normally we do the zipping of files for
No, no,
compress.
this that zip is different from this zip.
Okay.
Pranik, thus that is cryptographic zipping. So that
Hmm.
is different from this zip.
Okay.
Okay, and then the second thing is map. So let's say you got the names all in lowercase, but you want to convert them into uppercase. So what's one way in which you can do is all the names into uppercase. Okay. So let's say I have these names. So what I can do is for name in names and then can, okay, let's iterate in this fashion. and then I can, oh, sorry, I should have written range. Yeah, sorry. Yeah. So now it has converted into Alice, Bob, and then Charlie. Okay. So this is one way of doing it, but Python gives you more powerful way of writing this in a single line. So what you will do is you will write map, and then inside it you will write str.upper. This is a string function which converts the strings into uppercase, and then you will pass in the names. So what it does is it will pick each of these names and then convert them into uppercase and then add them into a list. So that new list is known as upper names. So if I run this, you will get this. All the names converted into uppercase. So let's see one more example. Uh, let's say you have numbers and you want to convert these numbers a into their respective squares. So as you can see, I have written a lambda function over here. Do you remember lambda function, guys, which I taught you in previous classes?
Yeah.
Yeah. Okay. So what it does is this is the input part and then this is the return part. It just squares whatever the number which it got and then returns it. So, and we pass an iterable over here. So it takes in each element and then returns its respective square. So 1, 4, 9, 16, and 25. And then so that's all about map. Any questions?
So, Mahesh, this lambda is also nothing but alternative for loop, right?
Yes.
Hmm. Okay.
Instead of looping, you can
Hmm.
use this map function. But whichever way is comfortable, you can use that. There is no hard and fast rule that uh, you need to use this. Uh, both time complexity will be same. So you can use them. Just I'm teaching you just so that for the completion sake.
Yeah,
And
yeah.
sorry.
Yes, yes.
Yeah. And then we have something known as filter. Let's say you are given a list of numbers and then you want to filter out only even numbers by eliminating odd numbers. So what you will use is you will use filter. Uh, Filter takes two parameters. First is the filter function and second is the iterable. So this filter function should return a Boolean value, so that depending on that Boolean value, true or false, it will take a decision to keep this element in the list or to remove it. So here we have lambda x and then x mod 2 is equal to 0. This is nothing but it checks if remainder of the number when divided by 2 is it equal to 0 or not. If it's equal to 0, then it's gonna return true. If it's not, then it's gonna return false. So when I execute this, you can see I have got 2, 4, and 6. If I add two more elements, 8 and 10, they will also be included in the list, because remainder of these two numbers when divided by 2 is 0, and this filter function return true. Similarly, I have one more example. Let's say in this case, we want to filter out the names whose length is greater than 3. So over here, you can see only Charlie, and only Charlie is greater than 3, not Bob. So what it does is it iterates through this list. It calculates length for each of the uh, names present in the list. And if it's greater than 3, it's gonna return true, else it's gonna return false. So here you can see it only printed Charlie. So this is all about filter. Even this filter is an alternative to for loop, and even zip is alternative to for loop. You can do the same thing using zip as well. So no issues in that. So any question, guys? Okay, I will take this silence as yes. Sorry, no. Yeah. Next, coming to try exception handling. So yeah, in this exception handling, we will have try, except, and then finally. It is similar to try, catch, and finally in Java. So let's say we are dividing a number by 0. So it will cause an exception. It will cause an error. So that error is handled in the except block. And whenever this error occurred inside try block, the code inside the try block uh, stops executing, and code inside the except block starts its execution when this error has occurred, and then finally executes when both of these blocks completes their execution. So as you can see, the code was inside try block, then it got an exception. So, and the statement inside exception was executed, and finally got executed uh, at the end. So let's say if we don't have the exception at all, then what will happen? Print X. Yeah. So in this time, code inside the try block executed successfully. So code inside except block didn't got its chance to get execute, and code inside finally got executed. So finally says that whatever happens, I don't care, I will execute in the end. So if we have multiple such exceptions which can occur, what you can use is multiple except blocks. So let's say if I enter number 0, so it got inside this 0 division error saying you cannot divide by 0. And let's say I enter some other thing other than a number. So if I execute this, then it will start saying invalid input, please enter a number, which is nothing but code inside the value error block. and finally got executed in both of the cases, irrespective of whether exception was zero division error or value error, or the exception didn't occur in first place. Yeah.
So, Mahesh, what is this zero division error and value error? Predefined something or what?
No, no, these are standard errors which comes with Python.
And what if we don't know what error it would be, like generic
Yes,
error?
yes, I will show you the code. Let's say I have the code like this. Let me use the same thing. And if you don't know any error, what kind of error, then you can write it like this: exception as E, and then you can print the exception. Then you can, this finally is optional. You can ignore it. So I'm writing zero, then it showed me division by zero error. Okay. If I write something else, let's say hello, and hit enter, it says invalid literal for integer. Okay. So in this way, you can handle it if you don't know what kind of exception it is. It's always best practice to add this block known as except exception as E in the end while writing all the exceptions. So in that way, you can handle even the edge cases as well. Is it clear?
Yes.
Okay, cool. Next thing is, how will this finally behave if we have a return statement and this try and finally are inside a function? So what happens in that case is, when the code starts executing in try block, it executes fully till it reaches the return statement. Once it reaches the return statement, it stops its execution and finally will get executed, and then this return statement executes in the end. So as you can see, I have written print inside try block and then print inside finally block, and then I am returning return from try in the try block. So when I run this, you can see inside try block, which is nothing but this statement, line number 3, and then it encountered return statement. So it paused its execution of try block over here. It came to finally block, and then it executed finally block, and then it came and executed the return statement inside the try block. But what if this return statement is present in the finally block? What will happen? Any guess? Anybody want to give a try? Yeah. So what will be the output of this program? Shall I create a poll? How to create poll? Guys, please let me know in the comments your answers. Is
Yeah.
it gonna return from try or return from finally?
First, finally block will execute, print
Okay.
and return as well. And
O-
then the last return of try will execute at the end.
But function can return only one value, right, Pranit? It can return once.
Hmm. Yeah, then it will stop by at finally.
So try
Confirm
block's
finally.
return will be redundant, you are
Hmm.
saying, right?
Yes, yes.
Okay. So this statement is redundant by Pranit. And let's execute and check if Pranit is right or wrong. Pranit is right. And he is right. Okay. So the same thing I have written over here as well. So this is nothing but a short summary uh, of try, accept, and finally. Any doubts in this?
No, Mahesh.
Okay, cool. Next thing we are gonna learn is about object-oriented programming in Python. So yeah, uh, all of you guys are comfortable with uh, any one of the object-oriented programming, right? Whether it's C++ or Java. Guys, if
Yeah.
you are so shy to speak, then you can comment.
Yes, Mahesh.
Okay. Likita, Arun, Likita, we were unable to hear you.
Yeah, Mahesh.
Okay. Arun,
Yeah. Please go on.
what about you, Arun?
Yes, sir.
Okay. Yeah. So, these are nothing but six most important definition of object-oriented programming. One is class. Class is nothing but a blueprint of object, and then object is an instance of the class. So if you want an analogy, then human being is a class, and Mahesh and Pranit, Likita, Arun are the objects of human being. And then comes the encapsulation, which is nothing but hiding the important information from the class. And then abstraction is nothing but hiding the complex logic and only exposing the necessary parts. And then inheritance is nothing but uh, using the code from old classes to the new classes. And then polymorphism is nothing but allowing the same methods to have different behavior. So in Python, class is defined like this. We will use the keyword class and then the class name. And then we have constructor defined like this. Uh, we will use the def keyword and then underscore underscore init underscore underscore. And we will use something known as self. So self is similar to this in Java. So this is used in order to reference the variables of the same object. So this is how we pass in the arguments of the function, and then this dot brand is equal to brand. This brand is nothing but the argument, and then this self dot brand is nothing but the variable of the class. This self dot brand can be accessed throughout the class by using the word self dot brand, or else if you don't use the keyword self, then its scope will be limited to this function. So in order to make it accessible throughout the class, you need to use the keyword self. It's a very important thing to do. And then you can define other functions. And if you want to use the variables of the class, then you need to give an argument, you need to specify an argument known as self. This self you need not to pass when you are calling the function. It's implicitly addressed inside Python. So, and then you can use all the variables. So what I have done is I have defined a class named as car, and then I have defined an constructor with the name brand, model, and then year. And I have initialized these three variables. And then in the display information, I'm just displaying all of this information. So in first thing, I have given the car brand as Toyota, and then model as Corolla, and then year as 2022. And then in for the second car, I have given the brand as Honda, and then model is Civic, and then year is 2021. So as you can see, I can call the function by specifying object name dot function name. So, and you need not to pass the argument self. It's implicitly taken care, and over here as well. So wherever self argument is there, you should not pass that argument when you are calling it outside the uh, class. So, and then when you execute it, it printed correctly 2022 Toyota Corolla. So in the same fashion, year, brand, and then model. So that's it. In next session, we are gonna learn more of object-oriented programming. Any questions?
Nothing from my end, Mahesh.
Okay.